In this video, we're going to talk about Hybrid Columnar Compression, or HCC, which is a feature of Enterprise Edition exclusive to Oracle storage, namely the Exadata, Oracle Database Appliance, and ZFS. What is Hybrid Columnar Compression? Well, it is a way to organize and store data by column rather than by row, which helps to considerably save space. We're talking 10 to 15 times compression ratios on average. And since data is stored in a columnar-oriented fashion rather than row-oriented, compression can achieve a higher ratio as all values within one column are the same type of data. Of course, depending on the type of data, you might see more or less compression benefits by using HCC, but that is a general statement around compression algorithms and data types. So with this compression ratio of 10 to 15 in average, IT managers can drastically reduce and often eliminate their need to purchase new storage for several years. For example, a 100 terabyte database achieving a 10 times data compression ratio will utilize only 10 terabytes of physical storage. Furthermore, HCC can considerably improve performance for analytics and batch workloads because they tend to perform massive SQL queries that need to parse several columns. So having columns stored together will reduce the amount of disk I/O needed in comparison with row-oriented storage. With HCC, you can compress entire tables or partitions, and this is particularly useful for customers having to store data for 5 or 10 years due to audits and regulations, and they have them in different partitions, allowing these partitions, well, to benefit from compression. Now, there are 4 levels of compression: query high, query low, archive high, and archive low, each one implementing its own compression algorithm. And query high provides a reduced compression ratio, 4 to 6 times on average, but it is optimized to increase scan query performance, so it's very popular in warehouse environments. As you go down, the compression ratio increases, but the read performance decreases. And this is optimal for any application with data retention requirements, but with very rare occurrences of queries. Now, HCC is a feature that is completely transparent to the database user. You can write your SQL queries without knowing anything about HCC. Now, in the next minutes, we're going to show you a demonstration on a real ODA of query high compression on an existing table in a database. The first step in our demo is to connect to the instance. And once we connect to the instance, we are going to set the timing on so that we can capture how long each of these different queries are going to take to run. First of the queries that we're going to run is a select count, and that is going to return the amount of values or amount of records in the table. And we're also going to check how big our table is, and that is 96 gigabytes. Now that we have confirmed this information, we're going to also check if there is compression already enabled for any of the databases, for any of the tables. And as you can see, no rows were selected. This is the moment where we can execute the HCC compression query. As you can see in the actual query, we are running a query high compression, and we are running 16 parallel threads. On the right-hand side, you can see that even though the compression is happening, we can still query our table. It took 14 seconds, as you can see in the SQL developer screen, but it is still accessible. This is because if you check again on the SQL command that we run on the command line, we run the compression in an online fashion. The compression took 12 minutes to complete, and now we simply verify again that there is indeed a compression enabled, as a query high compression enabled for our table. And now we're going to check the size of the table. If you remember, it was 96 gigabytes, now it's 6, and that means we have achieved a 16 times compression ratio. And as you can see on the right-hand side, Now running the same count query takes less than a second. Of course, you can play around with the different compression levels depending on your own business case. And remember that they are query high, query low, archive high, and archive low. Thank you.